The double star 6-pulse rectifier is a 3-phase rectifier that is used when the load voltage VDC is lower than, say, 50 volts. And the reason that it is used is because there is only one diode conducting at a time. So the volt drop over the diodes and the power dissipated in the diode is minimized. Now, as you can see on the right-hand side, there is a 3-pulse rectifier and consisting of diode D1, D3, and D5. And on the left hand, there is a 3-pulse rectifier consisting of diodes D2, D4, and D6. And they are feeding the load in parallel. Now this component that you see here is called an intergroup reactor, and its job is to divide the load current into 2 equal parts, so that half of the load current flows through the right-hand rectifier and half of the load current flows through the left-hand rectifier. Now, if we look at the phase notation on the right-hand rectifier, then we see that the starting points of the windings are marked on the outside, away from the star point of that 3-pulse rectifier. When we go to the left hand, we see that the phase notation is now on the inside at the star point. That means that the voltage here, V1, is 180 degrees out of phase with the voltage V4, which means that when diode D1 is on, then diode D4 will be experiencing its maximum negative or peak inverse voltage. So diode D1 and D4 will not be on at the same time, and since they are 180 degrees out of phase with each other. And when we now go to the primary winding, we see that this is the dot winding, this one is the asterisk winding, and this one here is the triangle winding. When the current flows out of the dot winding on the secondary, it means that it will be flowing into the dot on the primary side. And when diode D4 is forward biased, current will be flowing into the dot on the secondary side, meaning it will flow out of the dot on the primary side, giving us AC in the primary of the transformer, and therefore there will be no DC magnetization of the core, which is something that must be prohibited because it leads to a third harmonic problem and it leads to metering errors, etc. When we look at the line current here, let's call it IX, then and let's call this one IB, then IX will be equal to IA minus IB. Now we've got 2 3-pulse rectifiers operating 180 degrees out of phase with each other and feeding the same load in parallel.